Right. I'm going to talk about why I wrote a Windows resource compiler from scratch. First, an obvious answer is that the Zig compiler can't currently compile RC files, and there's an accepted proposal to add that capability to the Zig compiler. But that's not the full answer. But first, I want to talk about what a resource compiler is. Let's say you wanted to create an executable on Windows that shows up in the file explorer with an icon. To do that, you create an RC file that looks like this. It has an icon resource, points to an ICO file, as the icon. Then you run that through the Windows resource compiler, which is rc.exe. You get a res file, which is a binary file. You don't really have to worry about the format. And that gets passed in the linker, and it's linked into the executable. And Windows just picks whatever the first icon is in the file and displays that. You can also use resource files to add like version information that integrates with the properties window. You can have like shell extensions that add an icon onto files in the Explorer. You can define menus and dialogues that get loaded at runtime, and a few other things. But there are existing projects that do this, that they're cross-platform Windows resource compilers. There's WinRes from GNU, there's LVMRC from LVM, and there's WRC from Win. So my initial plan was to use these as a reference, like these are open source, the Windows version is closed source, so it's harder to figure it out. But the problem with that is that none of these are fully compatible with the Windows version. So as an example, here's a basic resource file. This is the ID of the resource, this is the resource type, and this is the data. This is a raw data block that has just a string bar in it. And we compile that, it looks like this. So you can see the type there, it's encoded as UTF-16, so 2 characters per byte, and then there's the data, which looks what you'd expect. But what happens if you put quotes around the resource type, around foo? You would think now it's just a quoted string. You'll probably parse into foo and then you'll get the same thing. But in this case, actually, the Microsoft version includes the quotes in the type name. And this example is actually one that all the different implementations handle differently. So if you pass this through WinRes, it does parse it as a quoted string. And you get foo as the resource type. In LVMRC, it errors and says can't use quotes here, and WRC also errors in the same way. So using those as reference kind of went out the window. Like I can't really trust that they match the Microsoft version, and that's really the only version that matters. Like there's no spec. There's not really anything except what the Windows version does. If I wanted to make it match the Windows version. So that left me figuring out how the Windows version works. Like it's just a black box. It's kind of hard to figure out. There's some documentation, but it's mostly about the inputs, the RC files, not the outputs. But a Microsoft employee, Raymond Chen, wrote a whole bunch of blog posts that do actually talk about the res format, like the output. So those were helpful, but they're not complete. So some techniques I use to help is just manually trying things, just writing weird resource scripts and seeing what happens. I also did some like very focused fuzz testing, property testing type stuff where I just like take one position and manually or just iterate over every possible byte, stuff like that. And eventually I wanted to get to like just general fuzz testing where every input is run through my version and the Windows version, and the outputs are compared to make sure that they're the same. But in doing that, I found that there's some weird stuff that the Windows version does. So I kind of figured that not everything should be matched exactly. So I kind of entered this loop of like figuring out how the Windows version works, deciding if it's worth matching that behavior, and then run into something I didn't consider about it, or I didn't have enough context, or whatever. Then have to go back and figure it out again, and then kind of go through this loop again. So now I want to go through some of the examples of some of the weirder stuff I found that the Windows version does. So here's an example similar to the last one, but now the raw data is just a number. And it works how you'd expect. It writes a U16 with the number value into the data of this resource. But this is also an accepted number literal with a superscript 2 character in there. And no, this actually works out to the value 1403.
That's reasons.
Yeah.
So for 1, 2, 3, it's pretty simple. Like you just take the character value of the digit, subtract out the character value of 0, you get the numeric value, and you multiply it by a multiple of 10, you get the number. And the superscript works the same way, but the code point value is now 178. So when you subtract out the 0, you now get a value of 130. So this is like a base 10 digit with a value of 130. So if you do the same math, it works out to 1403.
So cool. Oh, Microsoft, wow.
So this was found by one of those like focus fuzz testing things where I just tried every byte. But it seems to be because they're using a function called isW digit, like isY digit, the like Unicode version of a digit detection. And I realized that there might be other code points that it returns true for that I haven't tested for, because I tested this when I was only supporting Windows 12.52 code page. So with the full Unicode range, there may be more that I'm missing out on. And right now, my version reproduces this, which is probably a mistake. I should probably not allow these characters and say, like, the Windows version does something weird here, you should use these characters. So here's another example. This is resources that use a file name to get their data, like they read from a file to get their data. And it works pretty much how you'd expect. Like it can be a quoted string or an unquoted string. And the number over there basically gets treated like an unquoted string. It doesn't get parsed as a number. But this is also accepted. You can use arbitrary number expressions as complex as you want, and that whole thing is treated as a file name. But it's even weirder than that, because the file it tries to read from is, in this case, 0xf, or 0xff. It just takes the rightmost number literal in the expression, whatever it is, and then just tries to read from that.
Okay.
Gotta
go fast.
So this was found by just manually trying things. I just wanted to see like what happens if you put a number in there, what happens if you wrap parentheses around it, that sort of thing. I had no idea why it works this way. It doesn't make any sense. And my version will error if you use a number expression and suggests a quoted string instead. You can also specify version information. So it's like a tree of key value pairs, sort of. And what normally happens is that it will write the key value, and then it will write some padding bytes to get up to like 4-byte alignment again, and then it will write the value. But if you omit the comma in between the key and the value, it stops writing the padding bytes. And this is a problem, like this is a miscompilation, because parsers will expect the padding bytes, so it'll start reading off weird offsets and it'll just get completely mangled. So this was also found by just manually trying things. Again, can't explain why this happens. Comma having like a changing how what gets compiled is super bizarre. And my version always writes the padding bytes and then warns about the Windows version behavior says if you want this to behave the same, you should probably have a comma in there. So here's an example of a dialog that has a button that we want to start hidden. So to do that, there's these it's not operator that you can apply to flags, and so you do not visible. And so under the hood, these flags are just numbers, so we can replace them with numbers to make it more understandable. These aren't the actual numbers, but it doesn't really matter. And so this basically boils down to like turn on the second bit and turn off the first bit. They use the OR operator just because they're bit flags, and this is a little bit strange, but it's possible to implement. It kind of works. So here's that example again. The default is 1. And then you end up with 2 essentially, because the 1 is turned off by the not. But there's no real rules about what a not expression can be or when it can be used. So all of these are also accepted expressions. The first one almost looks like it makes sense. Like you would kind of expect the parentheses would get evaluated, now it would end up as 3, and then it would be not 3. But it works out to be the value 2. And the second one is just has to be a syntax error. That wouldn't be valid anywhere else. But for whatever reason, it also evaluates to 2. And the last one is just ridiculous. Like, good luck trying to figure out what's intended there. And for whatever reason, it also evaluates to 2.
Is this a JavaScript talk?
Yeah. Is there anything that evaluates something that's not true? Yeah.
Yes.
Like 3 plus 5. What is that?
I couldn't tell you.
What is WAT?
Yeah.
Yeah, so this was found also just by manually trying things, trying to figure out how the not expression works. I have no possible idea what to explain this, and my version only allows like not and then a number right after it. That's it. Try anything else, and you get in there. So here's another example. That the ID of a resource can be a number or a string, and it tries to figure out which one you mean. And the rules for that are kind of what you would expect. If they're all digits, it's a number, and if you mix them, then it's a string, not a number. And in dialogues, you can kind of refer back to another menu and say, this dialogue should have this menu, and so you would expect the menu in the dialogue should be parsed the same way as the menu defined elsewhere. But in this case, the dialogues menu is treated as a number. That ID is treated as a number because anything that starts with a number is just a number when you're in the dialogue. This works the same way as we saw before. Like you just subtract the 0 value and you get some arbitrary digit value. You do the math and you get some arbitrary number. And this gets even weirder because now you can use any character. So you can use characters that have a lower digit or lower value than 0. So that would end up in negative 15. But this is unsigned 16-bit integer, so it wraps, and you get some number close to the 16 max. So this was also found by manually trying things, and I have no idea why this happens. And right now my version reproduces this, but I'm definitely going to change that. Like those two things should be parsed the same, so I'm definitely going to change that. And this actually gets even weirder because dialogues, you can specify 2 menus as accepted, but only the last one gets used. But if the penultimate one is a number, then it forces the last one to get treated as a number regardless of what characters are inside of it. So this actually works out to this number value. So right now there's like 33 instances of some behavior that I intentionally do something different, like figured out that the Windows version doesn't make any sense. I do something different. There's 4 things I found that I haven't decided on yet, and there's a lot that I found that I just match it exactly, even if it's weird. And that this, to get back to this loop, like you never really exit this loop. Like, you can always run into something that you didn't consider, and then you just have to restart the loop all over again. And to give you an idea of like how deep some of these rabbit holes have gotten, at one point while investigating the font resource, I did a Google search that returned exactly one result. Like, it was for a technical note about the 16-bit version of the resource compiler from like the late 80s, early 90s, which apparently only exists in one place in the Google Index. So you might have noticed that a lot of this stuff that I talked about was just like stuff I found manually. There's not a lot of automated testing that found stuff. And that's because on Windows, bus testing is not that well supported. Like there's a WinAFL project that I got working, but it's slow and the generated inputs are not that great. And on Linux, Wine, or at least the version I was using, I need to test more, but it doesn't emulate RC, the resource compiler perfectly. So I can't really trust it that the fuzz testing would give me any accurate results. And I did use some fuzz testing just of my own code without validating the resource or the outputs. And that found bugs in my own implementation, but it didn't do any like correctness checking. But I did copy some inputs over to Windows and just do the validation on Windows on the generated set of inputs. That found a few things, but I still want to like get full fuzz testing working. For something actually specifically Zig related, in res files, there's a lot of like lengths and stuff like that that are encoded as like U32 or U16. So in the code, it's pretty common to have to incast like a slice length to U32, which can panic. So I kind of made it a policy to have, for every incast, I just went through them all and either explained why they can't fail or made it so that they can't fail, and then included an explanation. That allowed me to sort of behave predictably around edge cases that are probably pretty unlikely, but it's still nice to protect against. And the Microsoft version, when I tested it, it'll do weird stuff like it'll wrap the length and like restart it at 0 if you overflow. But all the arithmetic can also fail, and it's not as easy to just go through all the arithmetic in your code to make sure that it can't overflow. But that might change potentially. There's a proposal that Andrew has expressed some interest in trying out eventually in some capacity. And my understanding of it, I could be wrong, but it would mean that arithmetic would widen the range of the integer instead of overflowing. It would make it overflow during arithmetic impossible. And then that would mean all possible overflow would then like move down to an incast somewhere after all the arithmetic has been done. And so, as an example, right now, every line in this function can overflow and panic. But if that proposal goes through, then only the last line would be able to panic. Meaning that like that strategy of just going through every incast and sort of auditing if it's possible to overflow, that strategy would become like more viable or nicer. Which I think would be pretty interesting to see how it would work. In terms of real-world testing, Microsoft has a repository of just sample programs. Some of them are pretty old, but there's about 500 in there that use RC files. And so I wrote some scripts that run all of those RC files through all of the different implementations of the resource compiler, including mine, and compares the results and just gives a report about that. So here are WinRes and LVMRC's results. You can see there's some they have a lot of different res outputs that might be. I haven't checked to see like if those differences matter, but the unexpected compile errors are a problem because those are like valid RC files that they're getting a compile error for. And here are my results. And for every RC file that compiles, I output byte for byte identical res files compared to the Windows version. And as a demo, so this is on Linux.
If you're talking about Windows, use Linux.
So pop
As is tradition.
okay. So this is one of the samples running by Microsoft. The only change I've made is add in build.zig. So here's that build.zig. You can see it's pretty simple, and the only like new thing here is this, which adds in a Windows resource file to compile. And this is using a branch of the Zig compiler that adds my resource compiler into it. And, oh wait, we do need to make a change to the RC file because down here, Linux is case sensitive, so we have to make these match. And I'm also going to add in the icon file, which exists here, but for some reason it's not referenced in the resource file. So just to give it an icon, I'll add that in. And then
Is it implicit on Windows?
Yes.
Just grabs that up.
it just grabs the first
Grabs the
one,
first
whatever
one.
the first one in the file is. Yeah.
Usually it's alphabetical, unfortunately.
Good job, Windows.
Also, these resource files get thrown through the C preprocessor. It looks
Yeah.
like. I was gonna say it looks like it's just.
How many levels of
Macros.
wrong can you go?
Yeah, and that'll come up a bit later, but yeah.
Yo, Doug, I heard you like macros.
You can use constants you defined in there in your program.
Wait, yeah. Can you use
That is
macros?
actually
Oh,
no.
A little bit of Win32 programming.
Yeah.
That's why they do that. It's like, why?
So
Oh my goodness.
all we need to do to build this is give it a target. What is going on?
That's quite a path.
That repository has some pretty deeply nested.
Which is hilarious because Windows is where you run into this path is too long
Right.
issues all the time.
Yep.
Cat Flake 255.
Right?
File name is too long, path is too long.
So that worked. We now have an exe, and what I'm going to do is copy that onto a flash drive. I'm going to try restarting and booting
that's
into
right.
Windows.
So, I have a quick question on the old voting.
Yep.
Who hurt you? Who made you do this?
Nobody made me do it, and I definitely kind of went overboard with trying to match the Windows version.
That's a good time. I was thinking, like
You just keep going? Like, you just like, no, I'm going now. I'm committed to this insanity. Like, yeah, I want you on my team. I don't know in what position, but like, this year, like, nope. I'm just gonna keep going.
I was wondering if you ever considered opening RC up EXE in like Ghidra or different decompiler to see like, what it looked like.
Yeah, I was thinking
I have not considered that just because I'm not sure about the legality of it. I don't want to like.
Well,
Legal schmiegel.
of course, I never passed the bar, but a decompiler is just a way to look at the assembly.
Right.
So
Yeah.
As long as you're not like stealing the assembly and reverse engineering it directly.
in the assembly, feed it to ChatGPT, say, hey, produce C code.
Don't give me the C code for
Give me
this.
something that will produce this assembly.
No, I did. Now I need to see if LLMs are capable of taking just decompile.
Don't give me a macro.
and turning it into C.
in ChatGPT,
I need to look.
My grandma, before she died, always used to take raw execute the whole thing in a C code for me.
Freaking damn.
All right. So now we're on Windows.
Look at that icon.
We can.
That was very brave to dual boot during the
I
line.
was. You told me you were going to, and I couldn't. I totally forgot until just now.
Yeah. So that's cross-compiling a Windows boot application from Linux onto Windows, and it works. And actually, from when I was testing, like the RC file was the easiest part. I ended up like figuring out how to find an example that playing was happy with was actually the hard part. Like the CPP files, those didn't always compile.
Oh, like with the zip compiler.
Yeah, there's like also a lot of like file system stuff. Like the Windows examples take heavy advantage of case insensitive. All right, formatting is a bit messed up here, but
It's perfect.
It's on Windows now.
You gotta go fast. It's great.
the status of the project currently is that there's still more that can be done with bus testing, like I mentioned, but it's definitely functional enough to be merged into Zeta at this point. But the branch that I'm working on is not ready yet. There's still more that needs to be done to like integrate the error messages and stuff like that. And in the future, some stuff that might be necessary is, as I mentioned, as I just hinted at, there's a preprocessor involved here. You run it through a C preprocessor. You can include headers and a whole bunch of stuff. It needs to be like a decently functional C preprocessor. And the Windows version allows UTF-16 included files, which no other preprocessor really has support for. So a custom preprocessor might be necessary to add it in that support. And then eventually, because Zig is moving away from LLVM and more towards self-hosted linking and stuff, might need to add res linking into the self-hosted linker. But I haven't looked into that at all. And then here's a link to the project, and that's my talk.
I'll open a question.
Sure.
So, like, number literals had that issue where his W digit was returning true for like superscript stuff. Did you check if that worked for like identifiers on resources where you could have them be numbered or streams?
Yes, the identifiers and the type name use a completely different parsing thing. Like, if there's nothing consistent about anything really, and in that, the only like thing that breaks up the literals for IDs and types is white space. That's it. Anything else can be put in there, and it doesn't matter at all. Like, you can just put in anything, it'll accept it.
Is it all white space or is it just specific
Yeah,
white space?
it's all white space.
Okay.
And there's some, I forget exactly, but there's some like things that it considers white space that aren't really white space normally.
This makes me think there's some JavaScript to C compiler somewhere. That was
I don't know.
Because it feels like
the resource compiler is like extreme legacy software where like it was written for like the 16-bit version of Windows originally, and then there was a 32-bit version that was made. So that was like Windows 3.0 or 3.1 or whatever. And then from there, it's hardly changed really. So it's like code from like 1990 that's still running, basically.
Do you still have to deal with like the UTF-16 versus 8 and all that?
Yeah, that's a whole other can of worms. Like there's if I went through everything, this talk would be like hours and hours long.
I kind of want that talk because it's so ridiculous. I can't believe we kept going.
So for modern purposes, do they just expect you? I assume they just have what they need built into MSPC, or
Yeah, MSPC, like if you add
Yeah,
an
you just-
RC file in, it'll run it through the resource compiler, and it's bundled with it. Like that's
You never touch it, ever.
And there's also a lot of other like auxiliary compilers that are similar that I'll hopefully will not have to write a version of. But there's a lot more tools like this in the Microsoft.
Hopefully, but you're having so much fun. Looks like it.
How maintained are the other resource compilers that you found, like the LLVM?
I'm not really sure. They don't have the same goals for sure. Like there's stuff that WinRes like WinRes almost is kind of its own brand of resource compiler. Like it allows stuff that is kind of probably a good idea, but is not supported by the Windows version. Like the Windows version limits which resource types can use a file name, like, and which ones can use like raw data blocks. Whereas WinRes just allows any type from anywhere, like, which makes sense. Like, if you want to specify a resource using raw data, you should be able to probably.
Yeah.
But
I like at embed file and the Go version of embed file a lot better. This seems crazy.
yeah, this is more useful for like the stuff that integrates, like
Yeah.
Windows APIs read from resources within the exe. So
Right.
stuff that integrates with that, it's more useful for that than like arbitrary embedding and data.
Yeah, I guess it's just surprising that they didn't keep it up to date to some degree. It's like it's still.
I mean, the Windows like GUI SDK and APIs.
Yeah.
Oh,
There's
it's
like
all-
a million of them.
yeah, it's all well built off of Windows NT, like old shit.
Right.
They're getting away from it.
I bet it's
Finally,
I don't know if that's a
baby.
good thing.
So, how complex is the .red, like the actual binary format?
It's not very complex.
Not very
It's
complex.
actually pretty straightforward. Like,
So it's mostly the compiler.
yeah, getting to the .res stuff is the complicated part. The .res itself is like fairly straightforward.
So you could theoretically make like a different configuration file that will create that binary data that's not quite as complex. If you didn't want to support latency.
Right. Yeah.
You do. So
Right. Yeah. If you wanted to like write your own sane programming language for into a REST
Shots
file,
fired.
you could do that for sure. Yeah.
So sorry, can we go back to why? Like, where did the rabbit hole open up? Like, what was the?
Like you wanted an icon on your executables. I'm guessing the only reason this started. You wanted a Zig icon.
I guess there's two reasons. The main reason was just like Zig wants one, so I wanted to write one. The reason I went crazy with it is that my goal really was to get to, I wanted to be able to pass anything in and be able to like verify that my version works the same. So like I use fuzz testing a lot. I think it's really good, and I wanted to use it here. It's probably kind of a crazy use for it, but it would be really cool to just be able to like continuously fuzz and have like fairly high confidence that my version is like perfectly identical for the most part to the Windows version. And I couldn't really get that by just writing whatever tests I thought would. Like, manual tests are not quite there. Like I like generated tests a lot.
So to make sure I understand, what grabbed you by the foot and drug you into the abyss was
Right.
the tantalizing
Yes.
idea that there's a canonical implementation. I can just test against that.
Yeah.
It just needs to do everything, and you're gone.
Yeah.
I'd also love to see the 25 tests that failed from that one repo.
The repository has tests that just don't have some of the files they need, stuff like that, where it's like referencing a file that doesn't exist. I don't know where it came from. It's just missing, so I can't like.
So a lot of them wouldn't even compile with the official one.
Right. Yeah. Those tests that failed at the 25. Those are the tests, or those are resource script files that failed with the Windows version and Mac version.
I
All
think you should.
25 of them.
Yeah.
I think you should change your slide then, because like you're at 0. Like you should claim victory.
You have feature.
Yeah.
Yeah, claim victory right now.
Because I was thinking that they had some weird examples
Yeah.
where they like parsed numbers wrong or whatever example you gave earlier.
No,
Right.
you're perfectly wrong.
Yeah.
Be proud of that.
The number was green, so I assume
Yeah.
failed as expected.
Yeah, but like
And I can see how
perfectly
that-
wrong or something. Like
Typical Windows shit.
no, you would just say
Task failed
the
successfully.
test failed successfully. That's exactly right. Like because you did.
To the I promise this is a string identifier. I kind of missed the explanation for why that is a number.
Because you started.
Basically, it
Yeah.
sounded like if
So-
the first menu is a string or a number, it just like assumes that all the other menus are going to be the same.
Kind of. It's actually a bit more
It's worse than that.
Yeah. So you can have any number of menus, like it accepts any number, but only the last one matters. Like it takes precedence. So, but if the penultimate one, the one right before the last one, is a number, then the last one it's treated as a number no matter what.
Right.
So if you put another menu in there that was a string between those two,
Yep.
the last one would actually be a string.
Chef's kiss.
That's so good.
I want to know, what the code is.
Did someone like need this feature for like a tool that automatically generates?
I mean,
sounds
like
life by one. Yeah. It's like
But they like never noticed because they only expect you to put it once.
This is
Right.
JScript. It has to be.
Like all of these are like edge cases. Like this is not really a valid file. Like you're not supposed to do this. There's only supposed to be one menu. It should probably be an error to specify two.
they never
But it's just like cases where they're like they didn't do any handling. So it just whatever happens sort of thing.
So the idea that what it's doing to that string is just like a really bad hashing.
Yeah. It's very bizarre.
So,
It's all undefined behavior that you defined.
Right.
It's crazy.
I'm
I love it.
impressed by your dedication.
I have one more question. Do you think wine accidentally like fixed some of these issues when they,
No, the failures are weird. I don't really understand. I didn't look into
You get
it much.
different failures with wine.
Yeah, I mean it's not failures. It's just will like compile differently, and I won't really know why or what happened, right? Because it's still just like another black box. Not
Yeah. A lot of black boxes.
Yeah.
So what do you do when you're not reverse engineering random windows and things?
He helps add testing to my HTML parser.
I contribute to the Zig standard library.
Nice.
It's mostly Windows stuff because nobody else seems to do Windows stuff. And I do fuzz testing for the standard library. I've done that, like the tar.
What's your main office?
Yes.
We think.
I'm kind of recent to
Just
Linux.
enjoys the pain going back to Windows.
Yeah.
That's why-
started out
that's why I asked you
game
your name.
developer, so
I just want to know.
Windows stuff.
So your hobbies include using software to break other software.
Sure.
Yeah, Andrew Kelly has mentioned many times on his streams because I'll like listen to him. He's like, whenever I see that ski mask guy,
Yeah.
I know I can trust him. So that's you.
That's good. Yeah.
I'm only slightly sad you didn't do the talking about the top.
Yeah, that's not actually me in that picture. It's like It's a from from a TV show where the premise is it's a reality show about somebody in the witness protection program. So they have to wear a ski mask the whole time and have their voice modulated the whole time, like in real life. It's a good show.
I really do think you should show this to some Microsoft Distinguished Fellows on
Yeah.
campus, because legit,
Yes.
they
I
might find it interesting. I'm not like not being facetious.
agree.
Like,
I am actually planning on writing a gigantic blog post.
yes,
Listing every single thing I found.
because their research group is actually pretty solid, and they have some really good blog stuff, and they might actually find this really interesting because you're unearthing stuff that
Right.
they internally have no idea.
Some of them might even be able to answer some of the questions if
Right.
they have access to the source code.
Like, it would be an actual interesting talk to give up in Bellevue.
Yeah, some of the stuff I didn't mention also is like there are bugs in the Windows version where like if you do certain things, it'll write an unbounded file, like it'll just keep writing to a file infinitely.
Oh,
or
no.
It'll crash.
That never goes wrong.
It'll use infinite memory, stuff like that. Like there's
Wow.
actual bad bugs in there as well. Those were like the understandable, silly ones, but they're definitely like just scratching the surface.
Wow.
Is there anything RC that EXE will not do to your system?
I don't know. I mean, the other thing to note is
Can you heart bleed? RC.
Yes, you are.
with those examples.
Last but not
all
least.
of those examples, like normal files, don't run into any of these like edge cases. Like they don't hit any of my warnings or errors or anything. Like they're all like if you do normal stuff, normal things happen. But if you do anything weird, a lot of weird stuff starts happening.
Is there any way to like literally inject like another executable inside the RC and then you go down that route?
Yeah,
Okay. Yeah, I'm just wondering, like, he's already gotten this far. Like, there's a lot. Just crazy that you could go deeper.
There's nothing left to do but prove that it's Turing complete. I mean,
That would be something.